Wow, guys.
Okay. All right. Okay, so you got the 15 over 28 by multiplying the 15 you got by multiplying the numerator over the 4 times 7, you multiplied the denominators. It won't let me write up here. I can't write it. Okay, so we will do the same thing when it comes to rational expressions. We will multiply the numerators together, and we will multiply the denominators together. So my numerator here, I have a 2, and my second one, I have an x. So if I multiply those together, what would I get?
2x.
My denominators, I have an x minus 4 here, and here I have an x plus 1. How would I multiply those together? FOIL. Yeah, so let's FOIL that out. So we would take our first, so we would get our x squared. Now take your outer and inner and combine those. Negative 3x.
Minus 4.
Minus 4.
You're just multiplying.
You're just doing your FOIL.
You do the.
Okay. Now let's look at number 2. What am I going to do with that whole number?
Put it over 1.
So the first thing we would want to do is make the whole number a fraction. And the reason we do that is simply to keep our numerators together, denominators together, just where we know where it is. So we would rewrite that as 2 over 1, so we know the 2 is in the numerator, right? So you're going to multiply the 2 with the 1. And that would give you 8, and you multiply the 1 with the 9, give you the 9. So when it comes to your rational expressions, you will want to do the same thing. If you have, for example, that 3, you would want to rewrite that as 3 over 1. So now you know you're going to multiply the 3 with the what? 8. And that would give you 24. And then you'd multiply the 1 times the x plus 6. Well, that's not going to change it, right? So you could just bring it over. And your second one there, you have your...
Can you reduce the 24 and 6?
Can we?
No, because it's adding.
No, because they're together. Good, yes. They are, that x and 6 are connected, so no, you cannot. If you think you're going to do that, put those parentheses around them. Very good. All right? So when we look at the one right underneath that x plus 1, you would want to put a 1 under that. And then you could multiply across. So what am I going to do in that numerator?
8x plus 8.
Yeah, so what did you do with the 8? You distributed it. Absolutely. You got to have to distribute. So thank you. 8x plus 8 over the x plus 6. It's, yeah, I didn't leave myself enough room. It's a 6. Let me see if I can clean it up. That's right.
Are you allowed to factor the numerator? To do
Yeah, but you've already multiplied it in, so you'll just leave it. That 1 over there is really a simplified thing. Okay, let's look at number 3. What can I do to that thing? Yeah. Do you see your 4 in the numerator and the 4 in the denominator? Can we go ahead and cancel them?
Yeah.
Yes, we can. I would absolutely do that. So those would cancel and go to 1s, and that would leave us with a 1 over 9. So in this case, we can cancel before we multiply. Let's look at our rational expression. Can we cancel anything here? Yes. The x plus 3's will cancel. You've had practice with that with your graphing, your discontinuity, right? The cancellation. So let's multiply what we have left. If I cancel those, they do go to 1. Don't forget. They don't just go away. They're 1s. So that leaves us in the numerator really with just the 2x and the denominator with the x minus 1. Okay. And let's look at our next one. We have a 4 over 15 times a 5 over a 6.
Okay, so the 5 and the 15.
5 and 15 can be reduced. Anything else? Yeah, reduce it all. It's great. That way you have smaller numbers. So 5 would be 1, 15 would be 3. Thank you. Put another 5 down there. 4 would become 2, and 6 would be 3. So what's that give us? 2 ninths. So again, we did some canceling. So if we come over to our rational expression, it's not so straightforward. If I'm going to do some canceling, what am I going to have to do first? We're going to have to simplify. You're going to have to simplify that thing down. So if you have an x squared plus 9x plus a 20, x method. So factors of 20 that add up to 9. 5 and 4. Okay. What, can we do anything with the 2x minus 6? 2. That would leave us with x minus 3. Okay. Now, can we do some canceling?
Yes.
Yeah, a couple of things. The x minus 3s will go, and the x plus 5s will go. Remember, when they cancel, remember to replace them with the 1s. So all we have left in the numerator is, and the denominator we have a couple of things. So put the 2 first times your x plus 4. And yes, you could go ahead and you could multiply that back in if you wanted for a 2x plus 8. But this would be fine. Just know that if you saw that on a test, 1 over 2 times x plus 4 would be the same as 1 over 2x plus 8. Any questions on your multiplication? Okay, let's look at our last two here.
16 over 3.
All right. Now we're switching from multiplication to what? Now we're switching to division. How do we divide fractions? Yeah, so, and we change our division to multiplication. All right, so let's do that. So let's rewrite our 2/3. So this would be 2/3 times what? 8 over 1. Remember, when we divide fractions, it's the same as multiplying by the reciprocal.
You don't flip the first one?
No, just the second one. You don't flip
Always the second one?
Always the second one.
Well, it could be either way.
Nope. No.
Why can't you?
Only
Division is
Because then the numerator and denominator change.
take the reciprocal of the second one. You will change that completely. So yes. 16 over 3, yes. Yes, that is correct. Okay, so we're going to do the exact same thing with our rationals. So I'm not going to touch the 2x plus 4 over the x plus 3. What?
Reciprocal.
Yeah, take the reciprocal. So let's just kind of, I'm going to change it to multiplication. And what would be the reciprocal? X minus 2 over the 5. And we'll just kind of knock that out of there.
Where's the light out?
Yeah.
All right, so can I do any reducing? No, so we're going to go ahead and multiply. How am I going to multiply the numerators together? FOIL, so go ahead and put your parentheses around them.
2x squared minus 8.
Okay, so outer would be -4 and inner would be, does it cancel out?
Yeah, it'll
You're-
just be 2x squared
yeah.
minus 8.
Your outer and inner are going to cancel out on that one.
2x squared minus 8.
Yeah. And how are you going to do the bottom, the denominator?
5x plus 15.
Yeah, I'm going to distribute.
Can you explain it again? I don't know how you got it.
What- The x minus 2, I took the reciprocal. Division is the same as multiplying by the reciprocal. So I change the division to multiplication and I take the reciprocal. The reciprocal of 1 over 8 is 8 over 1. I'm going to do the same thing over here. I'm going to change that division to multiplication. And I'm going to multiply by the reciprocal. So I'm just going to flip this. So this becomes the numerator. This becomes the denominator. Okay? Any other questions on that one? Okay, let's finish our last one here. We have 3/2 divided by 1/8 would really be the same as, I need another color. What color we want to use?
3 halves times 8 over 1.
3/2 times, and then take the reciprocal of 8 over 1. And then you could do what before you multiply?
Reduce.
And then you could reduce. 2 and 4? No, 1 and 4. So 12, yeah. Okay. So let's do this last one here. I think what I'm going to do before I do anything is I'm going to go ahead and take that x squared plus 4x plus 3. And let's go ahead and use our x method on that. Plus 3 and plus 1. Okay. Now, let's change it to multiplication. So I'm going to change it to multiplication. And I'm going to take the reciprocal. So the x plus 3 times the x plus 1 will be in the numerator, and the x minus 7 will be in the denominator. What's going to cancel? Yes. The x plus 3's will cancel. So 4 times the x plus 1. I'm going to swing back this way. So that leaves us with the 4 times the x plus 1 over just x minus 7. So a 4x plus 1, if we multiplied that out, that would be a 4x plus 4.
What do we put in the step part?
Same thing.
Oh.